Hello students, how are you all? I hope everyone fine. So last class we learned definition of vector, types of vectors. Okay, today we are going to learn one very important concept called position of the vector as well as the two-dimensional and three-dimensional vector. Okay, so one very important concept, okay, it's position vector or position of a point. So listen, the position of a point P with respect to a fixed point O is a vector OP. Is a vector OP. Why the position of a point with respect to the fixed point is a vector? Vector andre no? Yeah, it has both magnitude and direction. Positioning ಎರಡು ಬೇಕಾಗತ್ತಾ? See, suppose someone asks, okay, how to travel to Udupi from Hebri. From Hebri ಅಂದ್ರೆ position fixed point is Hebri. ಹೇಗೆ ಏನು ಹೇಳ್ತೀರಿ? 35 kilometers. ಸಾಕಾ? If you just tell 35 kilometer, they may reach the Agumbe also if you not tell its direction. So you should give for them the direction as well as the magnitude. Then only they will reach the destination properly. So in the same way, okay, if I consider O is the Hebri and the point P is a Udupi, okay, then to exactly reach the destination for the person from Hebri, he must know, okay, direction as well as the magnitude of the distance. So ಎರಡು ಇರಲೇಬೇಕು ಅಲ್ವಾ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇರಬೇಕು, ಡೈರೆಕ್ಷನ್ ಇರಬೇಕು. ಸೊ okay, when you have a direction and magnitude for a quantity, that quantity is known as a vector. So position of a point P with respect to a fixed point is a vector. Nenpili is a vector OP. Remember, it's a vector OP. Initial position in the terminal position. What is the initial position? Oh, the terminal position is point P. So it's a vector OP. So vector OP represent position vector of a point P with respect to O. ಅರ್ಥ ಆಯ್ತಾ? So it's a position vector of the point P with respect to O. So position of a point ಗೊತ್ತಾಯ್ತಲ್ಲ, position of a point in a space or in a plane, in both case it is a vector because position ಅನ್ನ represent ಮಾಡಬೇಕಾದ್ರೆ direction as well as magnitude ಎರಡು ಬೇಕಾಗುತ್ತೆ. Okay, now I will give you one important note. Observe carefully. Consider a vector AB. Vector AB ಹೇಗೆ represent ಮಾಡೋದು? Yeah, like this. Then let O be the fixed point. Then what does this represent? This represent position of the point A or the position vector of the point A. This represent position vector of the point B. Correct? Already I took the vector as a AB. Now for this triangle, apply triangular law of addition. Triangular law of addition enpidya? Select two same direction vector OA and vector AB. So consider two same direction vector OA and vector AB. Add the triangular law of addition tells that when you add these two vectors, you will get the third, which is opposite to the remaining two. That vector is vector OB. So this is using triangular law of addition. Now in this expression, rearrange, take OA to right hand side, then you will get one very important expression. Vector AB is equal to vector OB minus vector OA. What is vector OB represent? Position vector of the point B with respect to O. Vector OA represent position vector of the point A with respect to O. So remember, any vector AB can be represented as the position in terms of a position vector as follows: position vector of terminal point minus position vector of initial point. ಯಾವುದೇ vector ತಗೊಳ್ಳಿ, you can represent in terms of its position vectors as follows. First you are going to write position vector of the terminal point minus position vector of the initial point. So please remember this concept. Any vector, see for example, if you want to write PQ, how to write? OQ minus OP. Any vector can be represented in terms of its position vector. So position of a point is a vector, remember that, and any vector can be represented in terms of its position vector. So position vector concept artha aithalva. Now using this position vector concept, we are going to learn a very important concept, the two-dimensional vector, or we are going to represent vector in plane. We are going to represent vector in plane. Just observe carefully, listen carefully, it's an important concept. So take a point in a plane, and that point is P of x comma y. I hope you know how to represent a point in a plane, alva? So take a point P of x comma y in a plane, then you know this distance is x, this height is y, alva? Idan geometry kaltidire. Let P of x comma y be a point in a xy plane. Now this is a very important one. I am introducing a new vector to you. Observe carefully. I cap and j cap. I cap is a unit vector. Unit vector and gottidalva, magnitude is 1. I cap is a unit vector along x axis. I cap is a unit vector along x axis, and j cap is a unit vector along y axis. I cap is a unit vector along x axis and j cap is a unit vector along y axis. Now observe carefully. In this diagram, what is OM? X alva. Now for x I'll multiply I cap. Okay, I'll multiply I cap, so then it will become a vector. Then x I cap will be a vector along x axis, right? Now, okay, I'll write this, the magnitude OM as a vector. Then what is the direction of vector OM? It is also along x axis. Okay, fine. So direction of both these two are same. Now let us check its magnitude. What is the magnitude of vector OM? X, because length of OM is x. What is the magnitude of vector x I cap? It is also x. Why? X will be real number, x will come out, and magnitude of I cap. I cap under unit vector. Unit vector under magnitude is 1. So its magnitude is also x. Magnitude of this vector is also x. Magnitude of this vector is also x, and direction is along x axis. So definitely you can equate, these two vectors. So I wrote here vector OM is equal to xi cap. I hope you understood why vector OM is equal to xi cap. Xi cap na magnitude and direction is same as that of vector OM. Similarly, remember, vector MP, okay, is also a vector in the form of y into j cap. Is also a vector in the form of y into j cap, because direction is along y axis, magnitude is same. So definitely you can write vector MP is equal to y into j cap. Okay, now use triangular law of addition to this triangle. Yeah, triangular law of addition and select first two same direction vector. Vector OM plus vector MP. Which is the third one? The OP, which is the position vector of the point P. So according to triangular law of addition, the vector OP can be represented as vector OM plus vector MP. Artha, this is using triangular law of addition. You already know vector OM is nothing but xi cap. Vector MP yj cap. So represent. So every vector, or the position vector of the point P, now you represent it as xi cap plus yj cap. So OP represent position vector of the point P, or the position of the point P with respect to O, and it can be represented as a vector xi plus yj cap. Here x and y are called components of the position vector of the point P, or components of the vector OP are called the components of the vector OP. So if you consider a point in a plane, it can be represented as a vector xi plus yj cap. It can be represented as a vector xi plus yj cap, where I cap and j cap are the unit vector along x axis and y axis, and xy are the coordinates of the point P from the xy plane. It is not only for xy, any vector, any point can be represented as a vector xi plus yj cap. Please remember that. Now, so using same diagram, see, after getting some vector, you must be able to decide its magnitude. Okay, remember that the direction already you understood from O to P. Now you have to decide its magnitude. Suppose, because if you don't know magnitude, if you know direction, you cannot use that vector anywhere. So vector and gotadmele, you must be able to decide its magnitude as well as direction. Direction board kantiದೆ from O to P. ಈಗ magnitude decide ಮಾಡಬೇಕು. So magnitude decide ಮಾಡಬೇಕಾದ್ರೆ use this right angle triangle. Right angle triangle, angle 90 degree, this angle is 90 degree. So use Pythagoras theorem, OP square is equal to OM square plus PM square. So that is OP is equal to root of x square plus y square, because OM is equal to x, PM is equal to y. So OP is equal to root of x square plus y square. Now what is the magnitude of vector OP? It is nothing but the length of the vector OP. What is the length of the vector OP? It's OP. So therefore the conclusion, the magnitude of vector OP is equal to root of x square plus y square. So remember here, if you consider a point in a plane, it can be represented as a vector xi plus yj cap with the magnitude root of x square plus y square. with the magnitude root of x square plus y square. So that conclusion I wrote here. Thus every point xy in a plane can be represented as a vector xi plus yj cap with the magnitude root of x square plus y square. This is the conclusion for this explanation. I hope you understood. So remember, in a plane you can represent a vector as xi plus yj cap, where I cap and j cap are the unit vector along x-axis and y-axis, and x and y are the coordinates of the point which you represent in a plane. Okay, so let me take one example. If I take minus 2 comma 3 as a point, it can be represented as a vector minus 2i plus 3j. It can be represented as a vector minus 2i plus 3j, and its magnitude is root of 2 minus 2 whole square plus 3 square, and 4 plus 9 equal to root 13. So magnitude of this vector is root 13, which is using square root of x square plus y square. Got it? Very good. So in plane, just remember this, every point can be represented a vector xi plus yj cap with the magnitude. That's it. So this is about two-dimensional vector. Now one step ahead, okay, I am moving to the next concept. We are moving from plane to space. Okay, so I am going to explain now how to represent a vector in space. Okay, listen carefully. That is called three-dimensional vector. Okay, whenever you represent a vector in a space, then it will be called as a 3D vector. 3D geometry, that's 3D vector. Okay. Every point in a space is of the form order triplets. Order triplet and P first piece. So take one order triplet P of x comma y comma z in space. It is a point in a space. Okay. 3D geometry list axis barate, x axis, y axis and z axis. 3 axis barate. So because of that, I am considering 3 unit vectors, I cap, j cap and k cap. So let I cap, j cap and k cap are the unit vectors along x, y and z axis respectively. Okay, I cap, j cap and k cap are the unit vectors along the x, y and z axis respectively. Now after this, okay, I am going to explain how to represent a vector in space using this diagram. Okay, observe carefully. First draw, okay, 3 mutually perpendicular lines. I hope you know it is not possible in plane. You can refer the corner of the room. Okay, it will represent always the 3D coordinate geometry, 3D Cartesian coordinate system. Okay, so rough diagram. This is not exact diagram. Consider 3 mutually perpendicular lines. Take one point in a space. Drop a perpendicular line to xy plane. This is 90 degree, remember that. Again draw one perpendicular line from that particular point to y axis, because this is also 90 degree, this is also 90 degree, remember that. Okay, artha agtide helodu? Ha. Now okay, if I take this as a point x comma y comma z from three-dimensional geometry which you studied in first PUC, you know that this length will be x, this length will be y, this height will be z. Now because of we assume ijk are the unit vector along x, y and z axis respectively, we can write vector OA as just like in the two-dimensional concept, xi cap vector OB is equal to yj cap and vector MP equal to zk cap. Zk cap. Correct? Huh. Now we have to obtain the vector OP. Okay, vector OP is this is a vector OP, alva. This is a vector OP. I hope you can see that. Now see this actually here it will be like this. Okay, okay, point actually in space, not in any particular plane. So you can use a triangular law of addition 2 times to get one very important information, that is representation of the vector in a space. So observe carefully. Yeah, let us use this triangle now. ಈ ಟ್ರಯಾಂಗಲ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಸೊ ವೆಕ್ಟರ್ ಒ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಅಲ್ವಾ, ಇದು ಹೀಗೆ ಬರುತ್ತೆ, ಇದು ಹೀಗೆ ಬರುತ್ತೆ ಅಲ್ವಾ, ಎಂ ಪಿ. ಸೊ ವೆಕ್ಟರ್ ಒ ಎಂ ಪ್ಲಸ್ ವೆಕ್ಟರ್ ಎಂ ಪಿ, ಕರೆಕ್ಟಾ, ಯೂಸಿಂಗ್ ದಿಸ್ ಟ್ರಯಾಂಗಲ್. ಐ ಹೋಪ್ ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್. ಓಕೆ, ಫ್ರಮ್ triangle OPM, Okay, from triangle OPM, using triangular law of addition, see these two are the same direction vector. Vector OM plus vector MP will be the same direction vector. So according to triangular law of addition, vector OP is equal to vector OM plus vector MP. I hope you will agree with this. Okay, now use this triangle. ಇಲ್ಲಿಯೂ ಎರಡು ವೆಕ್ಟರ್ ಕಾಣ್ತಿದೆ ಅಲ್ವಾ, ಒಂದಿದು ಹೀಗಿರೋದು, ನೆಕ್ಸ್ಟ್ ಏನು, ಓಕೆ ಯು ಕ್ಯಾನ್, yeah, so here also we have another vector. So this vector OM, see now I can represent this like this. Vector OP is equal to, you know, vector OM we don't know, vector MP is ZK, alva. So now we have to obtain the vector OM. See this direction is like this, so this direction should be like this because they are parallel, it's a parallelogram. Okay, so now from this triangle, which triangle, from triangle OAM, from the triangle OAM, I hope you can see that. Okay, these two are the same direction vector, so I can write using triangular law of addition, vector OA plus vector AM equal to vector OM, correct? Vector OA plus vector AM is equal to vector OM. Now vector OA and know xi cap, AM is same as that of OB and yj cap equal to vector OM. Now substitute this here. Therefore vector OP is equal to, you know, xi plus yj plus zk. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? So see, we got a position vector of the point P in a space. We got a position vector of the point P in a space as xi plus yj plus zk. Now using the same concept, using these two right angle triangle, okay, we can obtain that. I'm not going to explain, it's your work, just like the previous concept you try to get, okay, the using Pythagoras theorem, this answer, we can obtain magnitude of this as a x square plus y square plus z square. This is just like the two dimensional. This part I am leaving as a homework. Exam ಇದೆಲ್ಲ ಬರಲ್ಲ, ಬಟ್ ಕನ್ಕ್ಲೂಷನ್ ಗೊತ್ತಿರಲೇಬೇಕು. ಯು ಮಸ್ಟ್ ನೋ ಹೌ ಟು ರೆಪ್ರೆಸೆಂಟ್ ಎ ವೆಕ್ಟರ್ ಇನ್ ಎ ಸ್ಪೇಸ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಹೌ ಟು ರೆಪ್ರೆಸೆಂಟ್ ಎ ವೆಕ್ಟರ್ ಇನ್ ಎ ಪ್ಲೇನ್. ಕನ್ಕ್ಲೂಷನ್ ಬರುತ್ತೆ, ಬಟ್ ಡೈರೆಕ್ಟ್ ಕನ್ಕ್ಲೂಷನ್ ಬಂದ್ರೆ ನಿಮ್ಗೆ ಏನು ಅರ್ಥ ಆಗಲ್ಲ. ಸ್ವಲ್ಪ ಇಲ್ಲಿ ವರ್ಕ್ ಮಾಡಿ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಯೂಸಿಂಗ್ ಟು ರೈಟ್ ಟ್ರಯಾಂಗಲ್ ವಿಚ್ ಆಲ್ರೆಡಿ ಯೂಸ್, you will definitely get it. So what is the conclusion? Any vector, okay, therefore any vector in space can be represented as, okay, xi plus yj plus zk. Any vector can be represented as xi plus yj plus zk with the magnitude root of x square plus y square plus z square. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? ಇನ್ ಸ್ಪೇಸ್ ಎನಿ ಆರ್ಡರ್ ಟ್ರಿಪ್ಲೆಟ್ ಆರ್ ಎನಿ ವೆಕ್ಟರ್ ಕ್ಯಾನ್ ಬಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಆಸ್ xi plus yj plus zk with the magnitude root of x square plus y square plus z square. So in plane we represented vector as a point, as an ordered pair. In space we represent a vector as an ordered triplet, or vice versa. You know, a point can be represented as a vector in xy plus yjk form, yj form. In plane, in space, a point or the order triplet can be represented as a vector xi plus yj plus zk. So this is about two-dimensional and three-dimensional vectors. So I hope you understood. So remember that in a plane you are going to represent vector as xi plus yj, in space like this. Artha aita? So one more concept is there in this section. It is called direction cosines. Yeah, we studied position vector, two-dimensional vector and three-dimensional vector. Now one small concept related to this two-dimensional, three-dimensional vector, but very important, okay, for entrance exam. It's called direction cosines of a vector. Direction cosines of a vector. So listen carefully. Consider first a vector, okay, in plane. First I'll explain the same full concept for the plane, and I will extend that concept to space. Okay, so consider a vector in a plane as xi plus yj cap. You know what is I cap and j cap represent, and let this vector, vector OP, okay, makes an angle alpha and beta with the positive direction of x-axis and y-axis. That alpha and beta are the angles made by the vector OP with the positive direction of x-axis and y-axis. I hope you can see that in a diagram. Okay, now the direction cosines of this vector can be defined as follows. Observe carefully. If alpha and beta are the angles made by the vector with the positive direction of x and y z axis respectively, then the direction cosines and then adರಲ್ಲಿ cos function ಇರಲೇಬೇಕು. Then direction cosines of this vector AP are cos alpha and cos beta. What is alpha and beta? Alpha and beta are the angles made by the vector OP along with x and y, positive x and y axis respectively. Okay, so then direction cosines of the vector is cos alpha and cos beta. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು. ಸೊ ರಿಮೆಂಬರ್, ಇಫ್ ಯು ವಿಲ್ ನಾಟ್ ಗೆಟ್ ದ ಡೆಫಿನೇಷನ್, ಬಟ್ ಇಫ್ ಯು ಗೆಟ್ ಅ ಡೆಫಿನೇಷನ್ or define cosine direction cosines, then you can define like this. I didn't write anywhere, but you can definitely frame your own sentence. If alpha and beta are the angles made by the vector along with positive x and y axis respectively, then direction cosines are cos alpha and cos beta. Cos alpha and cos beta are called the direction cosines. ಅರ್ಥ ಆಯ್ತಾ? Okay, now use this triangle to understand what you mean by cos alpha, or use this triangle to get the direction cosines of a vector. So from this triangle, okay, e right angle triangle refer ಮಾಡಿ. What is definition of cos theta? Adjacent by radius or x by r. ನೆನಪಿದೆ ಅಲ್ವಾ? So x by OP. OP ಅಂದ್ರೆ ಏನು? The hypotenuse. Hypotenuse ಹೇಗಿರುತ್ತೆ? x square plus y square. So it is x by, so cos alpha is equal to x by root of x square plus y square. If you know the components of the vector, very easily you can find out its direction cosines. So the first direction cosine is x by the x component divided by its magnitude, root of x square plus y square and then magnitude, or remember like x by root of x square plus y square. ಅದೇ ತರ cos beta, above triangle you have to refer, this triangle you have to refer. ಇದರಲ್ಲಿ ಇದು adjacent side, ಇದು hypotenuse ಅಲ್ವಾ? y by r, so y by root of x square plus y square. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? ಸೊ ಇಫ್ ಆಲ್ಫಾ ಅಂಡ್ ಬೀಟಾ ಆರ್ ದ ಟು ಆಂಗಲ್ಸ್ ಮೇಡ್ ಬೈ ದ ವೆಕ್ಟರ್ along with the positive x and y axis respectively, then cos alpha and cos beta are called the direction cosines of that particular vector. When you know x and y, how to find the direction cosines? Say this: cos alpha is x by root of x square plus y square, cos beta is y by root of x square plus y square. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಯೂಸಿಂಗ್ ದೀಸ್ ಟು ಫಾರ್ಮುಲಾ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ಡೈರೆಕ್ಷನ್ ಕೊಸೈನ್ಸ್ ಆಫ್ ಟೂ ಡೈಮೆನ್ಷನಲ್ ವೆಕ್ಟರ್ ಎಕ್ಸ್ ಐ ಪ್ಲಸ್ ವೈ ಜೆ ಕ್ಯಾಪ್ ಆಸ್ ಫಾಲೋಸ್. ಅರ್ಥ ಆಯ್ತಾ? ವೆರಿ ಗುಡ್. ನೌ ಐ ಆಮ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಓಕೆ geometrically to get the direction cosines of a vector in a space. I'll just extend the concept, and similarly I'm using this, okay, you have to refer this to understand the next concept. So similarly, if vector OP is a vector in a space, how to represent a vector in a space? xi cap plus yj cap plus zk cap, okay, is a given vector. Then the direction cosines, okay, list component ಇದೆ, 3 component ಇದೆ. So ಎಷ್ಟು direction cosines ಇರಲೇಬೇಕು? 3 components, 3 direction cosines ಇರಲೇಬೇಕು. Then the direction cosines are, cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma respectively. Alpha, beta, gamma are the angles made by the vector OP along with the positive, along with the positive x, y and z axis respectively. Okay, x, y and z axis respectively. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳೋದು? Alpha must be the angle made by the vector along positive direction of x axis. Beta must be the angle made by the vector along with the positive direction of y axis, and gamma must be the angle made by the vector along with the positive direction of z axis. ಅದೇ ಆರ್ಡರ್ ಇರಬೇಕು. So when alpha and beta gamma are the angle made by the vector along with the positive direction of x, y, z axis respectively, then cos alpha, cos beta and cos gamma are called the direction cosines of the three-dimensional vector xi plus yj plus zk. ಅರ್ಥ ಆಯ್ತಾ? ವೆರಿ ಗುಡ್. ನೌ ಯು ಶುಡ್ ನೋ ಹೌ ಟು ಗೆಟ್ ಇಟ್. How to get the direction cosines of the vector when you know all its components, and x, y and z. Just like the previous concept, I didn't write the diagram. It's just like the previous one, using Pythagoras theorems, or using the definition of trigonometric ratios. You can find out cos alpha like this: x by root of x square plus y square plus z square. Adhe tara cos beta, y by root of x square plus y square plus z square, and cos gamma is equal to z by root of x square plus y square plus z square. ಅರ್ಥ ಆಯ್ತಾ? 2 ಡೈಮೆನ್ಷನಲ್ ಆಲ್ರೆಡಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಅರ್ಥ ಆಗಿತ್ತು ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ. ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಏನು ಬರಲಿಲ್ಲ, ಜಸ್ಟ್ ಎಕ್ಸ್ಟೆನ್ಷನ್ ಆಫ್ ದ ಪ್ರೀವಿಯಸ್ ಒನ್. ಸೊ ಡಯಾಗ್ರಾಮ್ ಬರೆದು ಇದು ನಿಮ್ಗೆ ಅರ್ಥ ಮಾಡ್ಲಿಕ್ಕೆ ಅಷ್ಟು ಈಸಿನೂ ಇಲ್ಲ, ಬೇಕಂತಿಲ್ಲ. ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ಲೈಕ್ ದಿಸ್: cos alpha x component by magnitude, cos beta y component by magnitude, cos gamma z component by magnitude. And alpha, beta, gamma are the angles made by the vector along positive direction of x, y and z axis respectively. And cos alpha, cos beta, cos gamma are called the direction cosines of the vector OP with xi plus yj plus zk as a component. ಅರ್ಥ ಆಯ್ತಾ? Now observe one very important result or information. You can consider this as an information or a result, but very useful for entrance exam, and even it's very useful for the board exam. When out of 3 direction cosines, 2 are given, third one you can find out using this easily. What is that result? Cos square alpha plus cos square beta plus cos square gamma equal to 1. The result, remember, very important information of the result. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Now I will show you why it is equal to 1. Exam alli bandru barbodu. Prove that sum of square of all the direction cosines of the vector xi plus yj plus zk is equal to 1. Hege prove madbeku? See this. You take the LHS, that is cos square alpha plus cos square beta plus cos square gamma. See, example you should write what is cos alpha, cos beta, cos gamma like this. Okay, this is a cos alpha, cos beta and cos gamma. Now I am not going to write again, I am just going to use it properly. What is the cos square alpha? X square by x square plus y square plus z square. Square root cancel aguttalla after squaring. Cos square alpha, idu cos alpha, cos square alpha plus cos square beta, y square by x square plus y square plus z square, and cos square gamma z square by x square plus y square plus z square. LCM is same, so take that as a common denominator, x square plus y square plus z square. So numerator will be x square plus y square plus z square. So enagutte cancel agi. What is the remaining? 1. That's it. So remember, sum of square of direction cosines of a vector is always equal to 1. It's not only true for 3-dimensional, even it is true for 2-dimensional also. You can check in the previous concept also here. So square and add, even in this case also you will get 1. It's not only for 2-dimensional and 3, it's everywhere. Sum of square of direction cosines of a vector is always equal to 1. So important result, please remember, cos square alpha plus cos square beta plus cos square gamma equal to 1, where cos alpha, cos beta, cos gamma are known as direction cosines. So I hope you understood what I mean by direction cosines, position vector, 2-dimensional vector, 3-dimensional vector, and all right. So I hope you understood that in simple part. Now we have one important result, very important result. Usually result and exam al keltare for 3 marks. Okay, and that result name is section formula. You first PUCL 10th standard lo kaltidere, first PUCL lo bandide. So I hope you know why we require section formula. Okay, what is the section formula in geometry? When a point P divides line joining the 2 points internally in the ratio m is to n, when you are finding the coordinates of the point, it is in a geometry. In vector we are not finding anywhere coordinates. Okay, we don't want anywhere coordinates, we want position vector. You to understand a vector you need position vector. So result is directly related to the position vector. Listen carefully. The statement is like this: if a point P with the position vector R divides the line joining the points A with the position vector A, B with the position vector B internally in the ratio m is to n, then the position vector of the point P is vector R equal to m into vector B plus n into vector A divided by m plus n. This result is very important in the sense you are going to get this result in exam directly. The use result barata exam alli for 3 marks. Okay, last exam allu kelidden 2020 exam allu idu question kelidden nenpide for 3 marks. Okay, so proof anna ನಾನು ಹೀಗೆ ಬರೀತೀನಿ ಹಾಗೆ ಬರಿಬೇಕಾಗುತ್ತೆ. ಕರೆಕ್ಟ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಸಿಂಪಲ್ ಆಗಿದೆ. 3 marks ಒಂದು ತುಂಬಾ ಸಿಂಪಲ್ ಕ್ವೆಶ್ಚನ್, ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ. Okay, so what is the meaning of the sentence? Okay, I'll explain through diagram. See, point P divides line joining the 2 points, okay, with the position vector A and vector B internally meaning in the ratio m is to n, andre ee distance m agutte, ee distance n agutte. Even position vector of the P is also known. What is that? Vector R. So ಈ ತರದೊಂದು ಡಯಾಗ್ರಾಮ್ ಬರಿ, ಸಿಂಪಲ್ ಆಗಿದೆ, ಏನೂ ಕಷ್ಟ ಇಲ್ಲ. ಡಯಾಗ್ರಾಮ್ ಬರೀದ್ ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಸೊ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಅಂದ್ರೆ ಒಂದು ಫಿಕ್ಸ್ಡ್ ಪಾಯಿಂಟ್ ಬೇಕು, ಅದು ಅದಕ್ಕೆ ತಗೊಳೋದು ಆಸ್ ಎ O. ದಟ್ ಪಾಯಿಂಟ್ ಇಸ್ O. ಕರೆಕ್ಟಾ? Now I'll explain how to get the proof. Okay, ತುಂಬಾ ಸಿಂಪಲ್ ಇದೆ. I'm just using the diagram, not writing any construction in there. This is a given data in terms of diagram. Okay, now observe carefully. From diagram we know that AP by PB is equal to M by N, correct? AP by PB is equal to M by N. Did you agree with me? Yes. Now this implies AP into N equal to PB into M, correct? Cross multiply ಮಾಡಿದಾಗ AP into N, PB into M. Did you agree with me? Very good. Now observe carefully. See, I'll convert this into vector. Illidane continue ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ because we need position vector. ಇಲ್ಲೆಲ್ಲೂ vector ಇಲ್ಲ. Okay, we have to bring the vector. So observe carefully. See, what is the direction of vector AP from A to P, correct? Did you agree with me? Direction of vector AP in the diagram is from A to P. What is the magnitude of vector AP? Tell me. M, correct? Magnitude of vector AP is M. See this distance, correct? Now n is a number, n is a positive number, right? When you multiply n to a vector AP, okay, the direction remains same. Direction is along A to P only. What is the magnitude of this? Okay, the magnitude of this is M into N, correct? Magnitude of vector n into AP is M into N. Similarly, PB magnitude is N. The magnitude of vector PB is equal to N, and M into vector PB is equal to M into N. So magnitude same, direction is same. Therefore, I can write this implies n into vector AP is equal to M into vector PB. This implies n into vector AP is equal to M into vector PB. Now we got vector, so we can bring here the position vector. Okay, so how to bring? Say this: n into vector OP minus vector OA, okay, equal to M into vector OB minus vector OP. You can split using the position vector concept like this. I hope you remember, okay, where you learned this. Any vector can be represented in terms of its position vector. So this implies n into vector R, vector O and then vector A, M into vector B minus vector R. So m into vector R, n into vector A equal to m into vector B minus m into vector R. So rearrange. Each hogi. So m into vector R, n into vector R plus m into vector R is equal to m into vector B plus n into vector A. Correct? So here which is common? Vector R is common. Take it outside. M plus n equal to m into vector B plus n into vector A. So this implies vector R is equal to m into vector B plus n into vector A by m plus n, and this is asked in the question. So observe carefully, m into B, n into A, adhan interchange madidre wrong. M into A alla m into B and n into A. So this result is asked, okay, here. So position vector of the point P which divides line joining two points A and B internally in the ratio m is to n is m into B plus n into A divided by m plus n. So idon important derivation example keltare, okay, for 3 marks. So learn properly and write the proof just like this only. Okay, so I hope everything you understood whatever we did today, right? So remaining part I will continue next video. Thank you.